Good morning. Hopefully everyone's having a good weekend so far. So this will be the final section for Unit 1, or before we have our test during block number 2 of this upcoming week. It's section 2.5, which is titled Model Direct Variation. Should be a fairly short lesson because I don't think there's too many examples I want to do from this. First of all, I should talk about what is direct variation because this might be new for some of you. Direct variation is given by the following equation. Y equals K times X. So in this case, we say that X varies directly with Y, or vice versa, the other way around. K is called the constant of variation. Now, a lot of this seems kind of new to you, but let me give you a good example. Let's say you're standing outside and you're 6 feet tall. So let me actually type that up. So scenario. You are 6 feet tall and stand outside. Your shadow is 12 feet long. Assuming that one's height is directly varied with one's shadow length, how long is a nearby tree shadow if the tree is 30 feet long? So again, you're 6 feet tall, shadow's 12 feet long, nearby tree 30 feet tall. How long is this shadow? And actually, it's 30 feet tall. Let me reword that. If you said 60, you're right. So the answer, 60 feet long. Because shadow to height is a 2-to-1 ratio. And that's the kind of the thing with direct variation. For direct variation, you want a constant ratio. So that means that y equals kx can be written like this: k equals y over x. Not ration, sorry. I meant ratio. So if two variables are directly varied with each other, those two variables will always be in the same ratio. Because again, k is a constant, never changes. Never changes. Okay. So now we'll do an example. Let's say example number 1, x and y vary directly. Let's also say that x equals 5 and y equals negative 15. Write an equation relating x and y and find x when y equals negative 4. Okay, so here's what we do. We use a new color, we use green. Remember, y equals kx. Negative 15 equals k times 5. So very simply, k equals negative 3. So our equation is going to be y equals negative 3x. So we took care of the first part. For the next part, find what x equals when y equals negative 4. When y equals negative 4 equals negative 3x. X equals 4/3. So again, very simple. Now, an alternative for finding x will be the following. We could have just said negative 15 over 5. Remember, that's y, that's x, from what we were told originally, is going to equal negative 4 over x. So negative 3 equals negative 4 over x. Multiply both sides by x. And then divide both sides by negative 3. So we could have done it that way as well to solve for x. But if you already have the equation, it's not really necessary to do that. But remember, when you have direct variation, you have two ratios of equal value. This also means that we have direct proportion. Direct proportion and direct variation are the same thing. Same as saying direct variation. Remember, a proportion, well, I shouldn't say remember, maybe you haven't learned this, but proportion is two ratios of equal value. Okay? So that's basically the case here. So obviously I had the ratio negative 15 over 5, negative 4 over something, and I found what x was. So we had two ratios of equal value. So that's in essence what direct variation is. You will learn in chemistry, if you're a sophomore, later this year, that there are certain properties of gases that follow direct variation. For example, pressure and temperature are directly varied, volume and temperature are directly varied. This is assuming that your gas is of an ideal state. You'll learn about this later when you get in chemistry. You also might see this in SAT exams as well. So what I'll do is let me pull up a word problem that I have from a SAT exam. So right now you're getting a chance to look at my directory, but I got nothing to hide. Let me find a good one here for all of us to look at. I think, where I put it. So I'm going to find it and then copy it to OneNote so we can work on it. It's considered kind of a challenging problem, even though it says medium level. You'll see why it could be a little tricky. Okay, here we go. So you're told, and actually let me fix this real fast. There we go. Okay, you're told the stopping distance of a car is the number of feet that the car travels after the driver starts applying the brakes. Stopping distance is directly proportional to the square of the speed of the car. So that means that if we call it stopping distance d, and the speed, we'll call it s, it's going to go k times, now careful here, s squared, because the square of the speed of the car. So it means that k equals d over s squared. Now you could make an equation like I did in this example for number 1, and then plug in 40 for the speed to find the stopping distance associated with it. But you know, this is an SAT exam. They don't care about your work. You just gotta get the answer. You know what? Let's just do a proportion, meaning let's find the ratio for each scenario. So 17 feet over 20 squared equals a certain number of feet, I don't know, we'll call it d, over 40 squared. You might want to use a calculator for this, but you are going to get 17 times 40 squared equals 20 squared times d. Essentially what I did is I cross multiply. You may have seen this in Algebra 1 a while ago. Multiply 20 squared to d, multiply 40 squared to 17. Basically you're multiplying both sides by 20 squared and 40 squared simultaneously. So you don't need to actually show all those steps, kind of consolidate all that. If you work it out, d will equal 17 times 40 squared over 20 squared, which is 17 times 1600 over 400. Those will cancel. That becomes 4 up top. So d equals 68. So it means if you're driving twice the speed, your stopping distance actually quadruples. This is good to know if you're 15 or 15 and a half and you're about to take your driver's test, the written test at least, and they ask what happens to your stopping distance when you double your speed. It doesn't double, it actually quadruples. So you definitely want to drive safe. Of course, we're not talking about driving habits, because I'm not really one to talk when it comes to driving habits. But all joking aside, the answer is 68. If you didn't square the speed, you probably would have had 34 as your answer, and you would have fallen for one of the traps that the SAT does when it comes to some of their math questions. So you really want to be careful when you do these problems. But of course, it helps to know the main concept. Okay, I didn't mean to do that. I meant to highlight it. There we go. Okay. It's not as reliable as it seems sometimes. Here we go. Yeah, direct proportion. That's the main concept. So I think you guys have seen enough to be able to do the classwork on Monday for direct variation, and as usual, I'll always walk around and help you out. So I think we're all set for the video for this weekend. So enjoy the rest of the day. Looks like it's going to be a gorgeous day today. And of course, have a great day tomorrow as well. And I'll see all of you on Monday. Goodbye.